theta W1. Then the final temperature will be theta F. Is that clear? So we are going to take the initial temperature of water, which is 25 degrees Celsius. So you get your cold water, you use your what? Your thermometer, you place it. Okay? You place it. The value you have, you record it down. Okay? Like in this thermometer, what you have here now is close to 27 or 28 thereabout, which means there is error already in this thermometer, like I said initially. So, but we are using 25 degrees Celsius, which is the room temperature. Is that clear? Okay? So, likewise also, the mass of aluminium. We are going to measure the mass of the aluminium. That you can use your beam balance to measure. But the mass of this metal that we are using is 50 what? Is 50 gram. Okay? 50 gram. So how do I convert gram to kilograms? Who have an idea? So we divide by 1,000. Okay? So divide by 1,000. That will give us 0.0 0.05 kilogram. Okay? So now, do you know why we are converting this to kilogram? Who can SS1 answer this? Why are we converting grams to kilogram? Because of the SI unit, System International Unit. Okay, we've agreed that the SI unit for mass is always what? Is always kilogram. Then another thing you need to take note of is the mass of the water. Okay? The mass of the water used. And also, in this case, we can assume we are using, let me see the water wave sheet. Okay? Let's say we are using 100 mil, which is 100 grams, okay? By 1,000. That will give us 0.1 what? Kilogram. Is that clear?
Are you following?
So now, the formula, general formula for calculating the specific heat capacity, we always carry out one assumption that is very important. That heat lost, okay, by the metal must be equal to heat gained by the water. Okay? That's to say, heat lost by metal is equal to what? Equal to heat gained by what? By water. Because once this water boils, okay, the metal is going to be very what? It's going to be very hot that you can't use your hand to touch it. So immediately we are going to transfer it to the calorimeter. And the calorimeter has a cold water, and that water is going to be what? It's going to be what? It's going to be hot as a result of the hot what? The hot metal. Okay? So based on this now, general formula for specific capacity is always the heat, quantity of heat is always mass times what? Specific capacity. We use C to represent it. Okay? And what? Change in the temperature, which is why we are taking the reading for initial and final what? Temperature. We have to subtract them from each other to get the change in temperature that will take place. Okay? So if that is the case, we've now said heat lost by what? Metal must be equal to heat gained by what? Water. So we take note of that of the formula, we write it in terms of this. Mass of what? Aluminium, which is the metal. Specific capacity of what? Aluminium, which is what we are looking for. And change in what? Temperature is equals to what? Mass of water, specific capacity of water, and what? Change in temperature. Is it clear?
Yep.
Okay? So, Now, this change in temperature is going to be now change in theta. What? Now this is what we have. We now have what? We now have 100, okay, which is the temperature of the metal. We subtract it from the final temperature we are going to get, okay? Mass of water, specific capacity of water is always a constant, okay? It's given by 4,200 joule per what? Per kilogram. Per what again? Per Kelvin. Okay? So, based on that, we can introduce 4,200 here into theta now. The first temperature we have here is this. So we have final temperature minus 25. Is that clear? Yeah. Okay, now, so let's go back to our meter. Okay, so we place the thermometer to see if it is up to 100 degrees Celsius. Okay, if the water have actually reached 100, but if it has boiled up to 100, this is 70. Once it gets to 100, we will do what? We will remove the metal. So it's counting. This is 73 thereabouts. So it's increasing gradually. Remove the what? The metal, okay? Gradually.
What is your hand?
Remove the metal. Quickly, we are not supposed to even waste time.
You can just transfer the metal without passing itself. Just transfer it.
Okay, so we can place it inside the calorimeter, okay? And you quickly, you stir, okay? So that you have an even temperature. You stir. Then you place your what? Your thermometer so that you can get a reading, the final reading. So you wait for it and see. This is 31, 32, 33. Okay? So you have 33 degrees Celsius. So we record it down. Okay? We record it down. Now, to finalize, you see.
Shift now.
33 degrees what? Celsius. Okay? Can you see it now? So the temperature of your aluminium was 100 degrees Celsius because that's what water boils at 100 degrees Celsius. So automatically the metal has 100 degrees Celsius. So you bring it in here. On a normal day, we are supposed to measure the mass of water plus what? Calorimeter when added together. But because what we are doing is just an experiment to explain the basic concept of specific capacity, that's the reason why we are not going into that. Okay? So if I substitute now, I have mass of this of aluminum was given as 0.05, right? That's what we use. Times what? Ca, specific capacity of aluminum is what we are looking for. 100, final temperature is 33. Is equals to mass of water is given as what? 0.1 times 4,200. Okay? Then you have 33 minus what? 25. This will be 0.05 Ca. 33 minus 100 minus 33, what do you have?
69.
67. So you have times 67 equals to 0.1 times 4,200. That's 420, right?
Yeah.
So you have 420. 33 minus 25. 8. Okay? So 0.05 times 67, what do you have? Anybody with calculator can do that.
3.35.
3.35 CA is equals to what? 420 times 8. 3,300 and what? 60. So we divide both sides by 3.35. 3.35. This cancel out. So CA is equals to
1,002.985.
1,000 and what?
1,002.985.
985.
Yeah.
Okay. So this is joule per kilogram per what? Kelvin. Now, can you see this value now? If you go home, you can Google what is the specific capacity of aluminium. You will discover that you will have something like 900 and something. Do you get it?
Yeah.
So when you subtract it, you will discover that the difference will not be much. The difference is the error that occurred during the experiment. As you can see, because of what we actually discovered from the gas, okay?
Yes.
The water could not boil up to 100. So, but if we have carried it up to 100 degrees Celsius, you will discover that you will get approximately 900 and something. Is that clear?
Yes, sir.
Any question?
No, sir.
So, we call it a day here.
Bye.
Excuse me.
You, Nancy, you are not